Mic check. Mic check. Okay, so we can hear ourselves. Cool. All right, we'll get right into it. So, hello everyone, welcome back. For those watching, so again, we're trying to tackle Conquering Physics GRE. We're working on problem number 2 in the classical mechanics section. And so this problem is actually working out what we have here on this right hand side is a setup where we have 3 blocks and they're each getting held up by 3 different strings. And the tension on the first string out here is called T1, the tension on the second one is T2, tension on the third is T3. And so the blocks have different masses. The first one has mass M, the second one has mass 2M, this one has mass 3M. So purely based on this problem should actually be based almost purely on intuition, because what it asks us is which one has what's the order of the tension. And so these are our 5 different options. And so um, kind of based on the intuition that I've built up kind of through doing a lot of different problems, what I could see is that the one that's going to have the toughest time is this T1. So this one should actually have the largest tension. As you can see, it's technically holding up all 3. Just think of a chain, right? Like the chain has little monkeys, and they could connect. Or in those movies that you see, like who is having the most difficult time? The one that's holding onto the wall, which is holding onto the friend, which is trying to save the other one. So this one, it's only hanging on to this one, so it's only pulling up its own weight. This one is not only pulling up its own weight, but it's also pulling up the weight of this other one. This one is doing the same. It's not only just pulling up its own weight, it's pulling up the weight of this one, which is pulling up the weight of that one. And so right away we could try to think and know, okay, does T1 have the least? Well, no. In this case, this one has the most difficult time in holding all of this up. So T1 isn't less than T2. So right away we could cancel off this one and this one. We know that these aren't all going to be the same, right? So we could rule these out as well. And so the only one we're really left with is this last one. So we know right away that it's E. The T1 has to be greater than these, unless this M is equal to 0, which we're assuming it's not. But just for fun, I guess let's try to work this out and see what are the tensions for each one of these, right? And so we know, based on our Newton's equations, we could just always do the sum of the forces. And since we'll only focus on one direction, so this will be the y, right? So we want to look at the sum of the forces in the y direction. So we're assuming that these aren't really moving, so there's no immediate acceleration. So we know that the sum of forces has to equal 0. And so when we look at this block M, right, what are the forces acting on block M? So we know we have gravity pulling it down. So we have minus mg, right? And we have this T1 pulling it up. So this is positive. And T2 is pulling it down. You can think of a friend, if you're hanging on, this one's pulling you down if you're just looking at this chain link. Minus T1, T2. Okay. And then, so this is our system of equation. And so for the second one, we look at this one for 2m, right? Again, we look at the sum of the forces for this one. And we find out we have 0 acceleration. We find out, okay, we have gravity pulling this one down, minus 2m g, and then we have T2 pulling it up. So we have plus 2t, and right here minus t to the third pulling it down. When we go to this last one, again we have the sum of the forces, and since the stationary, we'll say it's 0. So we have minus 3mg, and there's nothing pulling it down, so the only thing pulling it up is this T3 part, plus T3. And so what's cool is right here we have just this. When we rearrange, we end up with T3 is equal to 3 mg. And so now that we have this, we could plug this into here. When we pull this equation down, we have 0 is minus 2 mg plus T2 minus 3 mg. And so when we work this out, we get T2 is equal to 5 mg. And then again, now that we have these, T3 and T2, we could plug these in to this one over here, right? And so we have 0 is equal to minus mg plus T1, and T2 is equal to 5. It's minus 5 mg. And so when we solve for this, we get T1 is equal to 6 mg. And so as we can see, T1 is in fact greater than T2, which is in fact greater than T3. So this is just a quick calculation on how you could work this hanging block problem. In the future, if you have any questions, you can leave it down in the chat or the comments below, and I can do a further video to elaborate. Hope this helps. This is a quick and light video, and so bye-bye.